Okay, so solving trig equations. When we're solving trig equations, this is exactly the same as what you guys would have done last year. All we're doing now is using radians instead of degrees. So here it says to solve each of these to 4 decimal places between 0 and 2 pi. So that's just like exactly the same as between 0 and 360. Our first step is to figure out where is this going to be using cast. Right, so we're going to use the cast rule. We have a positive sign, so we're going to be in 1 and 2. So we need to find our related acute angle. Now our related acute angle is going to be equal to the sine inverse of 0.7451. Now this is so important, you need to be in radians. Be in radians on your calculator. I told you that the other day. You need to know how to put your calculator into radians. So our related acute angle is 0.8407. Now that is actually also our first angle. So therefore theta is equal to 0.8407. And it's also equal to pi minus 0.8407. Pi minus that, because remember, that's pi right there. So pi minus that is going to be 2.3009. Alright, looking at this next one, I'm just going to set it up. Okay, I think you should be able to solve it. First thing you want to do is look at cast, see where we're going to be. Now our related acute angle, when we're using our related acute angle, it's always helpful to just look at the positive value of our answer, or our ratio. Okay? After that, you're going to be able to solve for your related acute and find your two angles. Okay? Alright, moving on. This is exactly the same type of question, but this is the special cases. So what we need to recognize about this is that we can look at our special triangles, got 1, 1, root 2, and see what this is going to be. If you remember your special triangles, or you can kind of get rid of these, I know a lot of you rely on them, you can start to try to memorize the unit circle. The unit circle is a lot more helpful later on. But looking at this, we have a positive cos. So we've got C, A, S, T. We're going to be in 4 and 1. Our positive cos. Now, the related acute angle here is adjacent over hypotenuse, which is right there. So we've got pi by 4. Well, that makes everything actually a lot easier. So that means theta equals pi by 4, or theta equals 2 pi minus pi by 4, which is what, 7 pi by 4. Again, I'm going to leave the next one for you. The next one's just the other special triangle. Set up cast, figure out where you are. Remember that this is pi, this is 2 pi if you go all the way around. Whoops. Okay? Figure out what you're adding or subtracting 2 pi or 2 pi to get to the right quadrant. Okay, a couple of examples of actual equations here. Now these are the exact same as what we would have done last year, but again, it's just radians. You have to just get used to it. It's like talking in feet and centimeters. Not a lot of you know how many centimeters you are, but that's our actual official measurement in Canada. You should know how many centimeters tall you are, or how many kilograms you weigh, but not a lot of people know that. Those are our measurements. Just like radian is a more true measurement in math, it's just a more accurate measurement for a lot of other things that we work with. So with this one, I'm going to move all of my coses to one side, move the numbers to the other, and solve. So we're going to have 3 cos, oops, sorry about that, not 3 os, 3 cos x equals 1. And we get cos x equals 1 over 3. Now I know that this is positive, so we have our cast. So cos is positive here and here. So we're going to find our related acute angle. Again, calculator in radians, not in degrees. So we're going to have our related acute angle is equal to the cos inverse of a third, which is 1.2309. Okay? Now, that would mean that x equals 1.2309, or x equals 2 pi minus 1.2309, which is 5.0522. Okay, and there's our first one. Our second one, you guys are going to do it exactly the same. Okay, the one trick, you need to expand that out. Collect all like terms. Check your values. Check cast. See where this is happening. Okay? I'm going to do the last one with you. It's normally a question I would leave, but I think it's a good one. Okay, so we've got sine of something equals a half. Now a half belongs to this triangle. We've got 1, 2, root 3, pi by 6, pi by 3. Okay, so we've got this triangle. Sine is opposite over hypotenuse, so opposite over hypotenuse. So we've got 1 over 2. So what this says is that this, our related acute, is pi by 6. Well, that's telling me actually that x plus pi by 2 is going to be equal to, oh, we got to see what quadrant we're in. Sorry, we're in 1 and 2. Cast. 1 and 2. So x plus pi by 2 is going to be equal to, well, pi by 6, or, which this one's the easy one, so we'll finish this one actually. So that means x equals pi by 6 minus 3 pi by 6, which equals, ooh, is that right? Yep, equals negative 2 pi by 6, so negative pi by 3. All right. Or, now this is the harder one, or x plus pi by 2 equals, we're in the pi minus pi by 6. That's the second quadrant. Okay, all of this stuff was done in quadrant 1. Okay, that's Q1. Stuff going on now, down here, is all Q2. Okay, and all we're doing is setting that whole angle that I underlined at the start equal to our answer. Our answer here is pi minus pi by 6. So now we're going to get x equals pi. Oh, let's actually make this all in terms of pi by 6. So 6 pi by 6, that's our pi, minus pi by 6, that's that value, minus 3 pi by 6, And we get pi by 3. 2 pi by 6, which reduces down to pi by 3. So our x value equals either pi by 3 or negative pi by 3. Those are a tough question, because you need to recognize the whole thing is equal to something. Okay, we'll take up those other 2 questions in class tomorrow, and that is the end of the note, so I'll give you the worksheet as well.